I'm Christoph Mayr-Dorn. I'm very happy to present this work on automated process-centric quality constraint checking. And this is work with my colleagues, Vierhauser, Stefan Bichler, Felix, Keplinger, Cleland-Huang, Alex and Egyed, and Thomas Mehofer. So we're quite a broad collaboration going on. And I jump right into the context of this research work, which was safety critical systems and supporting engineering in these aspects, these systems. So one example we have here is a remote tower that can be used where our industry partner provides voice communication solutions. And typically these systems have to be of high quality, not just because you want to have no bugs, but at the same time you also have string and regulation requirements in order to even being able to sell this kind of software. So you have to follow certain processes, you have to follow certain guidelines, certain traceability rules. And typically these tend to get quickly very complex, not just the air traffic management domains, also in the medical domain. And there's generally a challenge by companies to ensure that developers, the engineers, follow a specific development process, but also that the quality assurance constraints and so on are also followed. So perhaps to just give you a little bit of an idea how a simplified process model looks like at our industry partner, where we look at the stage where we have high-level requirements that map to subsystems and design specifications, map down to low-level requirements, function that again map to function units and low-level specification, test cases, just some of these artifacts that are used in that scenario. And then you have, but this is just knowing what are the artifacts, some of the artifacts that are used in the engineering process and established in engineering process. And then we also have the process steps such as reviewing how high-level and low-level requirements map to each other, how they are covered, then refining them, updating the specifications, making sure that traces are correct in reviews between different artifacts, then continuing with the implementation, then again doing another additional reviews for coverage of traceability. And typically these kind of processes are described in some order. Often you have them perhaps as a PDF. Virtually never, and this is not just for this company, but it was another study by others on how formal are these processes. And typically you don't really want to have them extremely formal and force them onto the developers, but because this, I mean, this is known now for almost 35 years or so, that forcing a process onto a developer and string it so that the developer cannot deviate from that process is not a very good idea, because you need this flexibility. But nevertheless, you still want to have some process guidance going on so that developers know what to do and when to do something. And the challenge typically is that what we also got from our industry partners, that the complexity is quite overwhelming, because sometimes they work on multiple projects at the same time. These projects have different standards that have to be followed. And there are a lot of these checks and what are the traces correct and so on. There can be error prone because you have to click a lot through different tools, because typically not all the artifacts are available in the same tool. They can be a little bit tedious because you have to click around a lot, because the things change a lot. You can't check them that often. And so they're often also informally defined as processes. So the question is, when exactly do I need to ensure that a quality constraint is fulfilled? And so often you do these quality checks by a separate engineer, by a separate department, and you get delay typically quite late when the developer has most often already moved on to another task. Then they have to be disrupted and said, well, look, hey, you forgot a trace here, or you forgot to complete this artifact status over here. And so you kind of disrupt the developer, and they have to think, okay, back 2 weeks ago, where was I when I was doing this? What would be the perfect artifact to ensure this constraint? And so this is a little bit inconvenient, and it's kind of, it works, but it's not ideal. And so why is it now important to address this aspect? I mean, this has been for this aspect, this problem, this challenge is there for the last years, for the last decades. And so with one of our quality engineers at our industry partner, he mentioned that 30% of his time is just spent on coordination with developers to fix those quality assurance aspects. And the load on that engineer is quite high. So we had to look at 109 sub-processes with 6 real constraints, which are only a subset. And these constraints actually span over 14,000 connected artifacts via the trace links. And looking at these 109 sub-processes, we saw there were 27,000 change events that would result in almost 30,000 artifacts to be checked over and over again to make sure that at every single change afterwards, the quality constraints are fulfilled to give immediate feedback. And so this is kind of quite a challenge, and this is why it can't be done in real time at the moment manually. And then we have the additional difficulty that the developers don't want to go in a separate tool and check whether the work is correct or not. So you want something to have non-intrusive. And another thing what you have is developers want to deviate from the process, so you can't check too tightly what they're doing, and otherwise there will be a lot of false warnings. And this kind of gives the context a little bit for our work, and that we kind of now came up. There's a lot of work in this respect of process support in the mid-90s, but now we actually have the ability to connect more easily to those tools and to evaluate also this much better what is really needed by these development teams. And so what we proposed and started also evaluating is called the passive process execution environment, where you have teams like different stakeholders, such as system architects, developers, team leads, and quality engineers that work with the given tools such as Jira for issue tracking, Jama for requirements, revision tools, and so on. And these follow these semi-formal processes and definitions and standards. This is ongoing for years. This is regular work, but it's, as I just mentioned, this is the tedious part here to check the quality assurance. And our approach now is that these tools are better and better to be observed. So we have tool connectors, we have information that comes into our framework. And what we also did was we take, together with process engineers, these specifications and make them executable. And executable here means not I enforce a process onto the developer, but rather I have something now in the background running that represents what my process looks like. So by having these change events continuously coming in, I can check, my process step 1 has been started. But it doesn't mean that the developer has to say step 1 has been started, but rather we just observe from the changes in the different tools that step 1 is now complete or started. And so we can build up gradually what is the status of the process, what are the constraints, in what state are these constraints, and by not having the developers actually have to interact with this engine and by having the freedom available in the tools, we have now this approach that we do this in the background, we do this passively, and the developer actually can deviate anytime he or she wants to. But from this process engine, we can get then some feedback back to stakeholders saying, okay, to what extent are you following the process? To what extent do you fulfill these constraints? Are you actually supposed to start already, or are any preconditions still missing that keeps you typically from starting the step? Nevertheless, allowing the developer to deviate and prematurely start, for example, a step. And the key concept behind doing all that is that we do this, as I mentioned, this passive tracking. So the developers stay with the tools that may deviate, but in order and also to have quality assurance constraints as first-class citizens in the process model. So we have explicit constraints separate from transitions in the process that can tell us, okay, well, this step was officially declared complete based on what information we have, but certain quality constraints are not quite met yet. And what we do then is for each step that is done in the process, we track for this step roughly what is the supposed state. For example, is it available, or so is it enabled? So are the preconditions fulfilled that it should be worked on? But actually, if perhaps this is not the case, but then we track also, we have indications that actually somebody is working already and that it's already active. And so we have can compare this to, in this case, finite state machines, and say, okay, well, actually, you're not supposed to work on this or not, but as you are working on it, I will also do your quality assurance checks. But be aware, as long as you're deviating, you can't be 100% sure whether your quality constraints are 100% fulfilled. There might be still some upstream changes that you have to react to later on. And we put all this into a web-based prototype that we managed to deploy our industry partners, but couldn't do extensive friendly user testing yet due to COVID-19 for the past 2 years now. But there's a YouTube video available that you can check out where we show how you can, for each of these process steps, you could then dive in and see, okay, which constraints are fulfilled or not fulfilled, and for those not fulfilled, have a link right back into the tools where this thing can be fixed, so that you get the developers supported in where should this actually be changed so that they fulfill the software, the quality requirements. But what we could actually do is for evaluation is we look at available data sets. So one of them is from the Chronology project, which is an open source system for unmanned aerial vehicles, where they use Jira for requirements, hazards, bugs, features, and so on. And all these artifacts go through some mini processes, and for these are specified certain constraints. And so we have for between 36 and 211 process instances for which we did test our approach. And also from our company partner, Frequentis, they do these air traffic control systems. We got, they use Jira for work packages and Java for requirements, design definition, test cases. And their one process definition is roughly the 4 steps you saw in the motivating scenario in the beginning. And there we took the data for 109 process instances. To give you an idea what the constraints are, so for chronology, they're more simple, such as issues, tasks, issues of type task need to trace to one or more design definitions. A hazard needs to be mitigated by a requirement. For Frequentis, we have more complex ones, such as no traced low-level requirement may have traced another sub-work package with the status other than closed, or traced low-level requirements have to have at least one link to a test case matching the requirements verification method. So mostly are centered around traceability, but also diving into the details of the artifacts, not just whether a link is there or not. And what we did then was we took the change history of all these artifacts that are available. We then basically replayed all the changes to the initial state of that artifact, and then one by one, each change, we kind of replayed the change and progressed through the process. And at each of these changes, we could then check what state is the process in, and which constraints are violated, which ones are fulfilled, and is somebody downstream starting with a step that they were not supposed to start yet if they would follow the process or if they would adhere to the process constraints and quality constraints. And so perhaps just briefly, not diving too much into detail into this figure is, so we had to look at the processes, whether they were always okay or just at the end okay, and also those that were incomplete, whether they also progressed beyond a certain state while violating this. And perhaps what was the main takeaway is, so the open source system obviously was not as adherent to the process because they're mostly students who were working on this. Well, we looked at also the process at our industry partner, and there we saw, well, most of them were actually done correctly right from the first time. The rest were kind of repaired, so there were perhaps some changes afterwards that made the traces complete. But there also were some incomplete ones that were not quite okay yet. And for that, we checked manually and saw, okay, sometimes these are corner cases, or sometimes there were some forgotten traces that were, where all the artifacts were there, they were linked in the comments, so just saying, okay, well, look here, the test cases are these and this and this, but they were not officially traces, and therefore they kind of were missing from were not available to the process engine, therefore flagged. We also noticed some incomplete processes that were actually officially supposed to be done. And here we saw that sometimes developers just forget to check some boxes in Jira or so. And therefore, kind of the issue is doesn't reflect reality. So the process is actually all done, but there was just this checkbox not done. And also here, so we see the benefit that could here support developers saying, well, look, this process is long due over. Did you forget to do something, or did you really not just finish this? So kind of pointing to having complete and accurate representation of developer status in the actual tools. Yes, so these were the ongoing and future investigations is now actually with users in the field to check how much are quality engineers benefiting from this. So how much does their work become less tedious? How much can they now focus more on corner cases and really improving the process? And also, how much are developers benefiting? Is it for them that they now feel more monitored and work outside the system even more, or are they actually also enjoying this so they don't get interrupted 2 weeks later saying, well, you didn't do that, or immediately see, okay, I need to do this and quickly continue with the next task. And also in the spirit of Leo J. Osterwald, who said processes are software too, the question is, how does this whole construct of processes and can be managed? So how do you edit this? How do you use this information? How do you handle variations across different teams? How do you test these processes? How do you update this process, evolve them over time? Because in larger companies, now we started also one project with Bosch, there is actually a huge number of processes that somehow need to be managed, and they have become a little bit complex. And so we started trying to do some visual programming, like we have Blockly for these processes. We're not quite happy with that yet, but we're trying out what would be a mechanism for, let's say, not programmers, but process engineers and quality engineers to specify all these constraints. And with that perspective, I thank you for your attention, and I'm now available for questions.